The Great Lakes Energy Education Center is part of Northeast Wisconsin Technical College, and we train natural gas construction workers. We train linemen for the electrical distribution program, utility engineering students, energy management students, and solar energy technology. Is the whole purpose of this new building. We moved all the departments over here, and the goal of this building is to be net zero. We're not there yet, but we're headed that direction. As you can see here, we've got a model that one of the students built of one of the renewable energy sources. Lab roof of the Great Lakes Energy Education Center, and as you can see, we've got east-west facing modules. This is all student-driven projects. They design the systems. It might look like one system, but really it's 4 different technologies, microinverters, 2 different string inverters, and optimizer system on the back row. Each of these systems are about 12.5 kW each. So what a great comparison. Again, east-west orientation, so we can get about twice the capacity on the roof with maybe 1.5 times the energy output. So you pay a little bit more, but you can certainly cover a roof with solar. As you can see, the empty space in the background, that'll all be for another comparison of south-facing modules, south orientation, that the students are working on right now. In addition, there'll be some pole mounts. We're going to put an awning across the front of the building, and then there will be a large, meaning 20 kW ground mount system with 6 more electric car charging stations built in.
Roof, we have about 99 kilowatts actually of solar PV, and all of that electricity comes in as DC, direct current power, and is changed to AC current using this inverter system that we have here, which is a SolarEdge inverter system, and it's hooked up to different circuits. We can see the different voltage and wattage right here on those. And then the student installed solar arrays have used a variety of inverter systems, Solectria, Fronius, as well as a SolarEdge system. And in our building, we currently have all the PV coming in through one panel. And in that way, we can use a current transducer to read how much power is being actively produced. We can track it for each of these systems, and then we can compile it and show you on the screen downstairs how much solar is being produced at that moment.
Okay. So here we are in the Great Lakes Energy Education Center, and we're looking at an energy kiosk, just some comparisons of the energy that we produce versus the energy that we buy. Again, the goal is to become net zero. We're working on it. Right now we're producing 90 kilowatts up on the 2 roofs that we have equipment plugged into, with the upper roof being 60, a little over 60 kilowatts, and the lower roof being about half of that. The upper roof has 96 kilowatts worth of PV, and the lab roof that the students installed has half of that, 50 kW. So in the background, you can see our geothermal system, at least the heat pump units, compressors, and out back we've got just over 40 wells, 300 feet deep, underneath the parking lot that we're extracting heat from to help air condition and heat this building. We also have a big heat reclaim wheel for the outdoor air that we bring in. We can save the heat from the exhaust air side as we're bringing in that minus 20 degree outside air come winter time. What we see along the wall here is just primarily backup natural gas for perimeter floor heating and domestic hot water.